Okay, we are continuing with the algebraic expression. Let us see what the main process of factorizing algebraic expression. But we must know the differences in the expression. Basically, we say an expression ax plus b, where a and b are constant, is called linear expression. Good. Linear expression of x. Let me use of x, linear expression of x. The expression in the form ax squared plus bx plus c, where a is never equals 0, where a is never equals 0, and a, b, and c are constant, is also called quadratic function. Now we are going to look at the various ways in which we can factorize the function. As we can see, basically when we have got a x squared plus bx plus c and we want to factorize, it is difficult to factorize when it is 3. The previous examples we did, we realized that when we have got 4 terms, we can easily group them, but this one has been given in a form of 3. So how are we going to work out this? The first method we are going to consider is the factorization, but we have several methods of the factorization. I will start by introducing the aspect I call the tree method. So we are factorizing using the tree method. Now, how does the tree method works? How does the tree method works? The tree method, we use a common tree. The general quadratic function is given as ax squared plus bx plus c. So we just draw our simple tree like this. Let the tree be straight. Just draw our tree, normal tree, a bar for division, and the second horizontal bar. Then we put the ax squared on the left side of the tree and put the constant at the right side of the tree. Then we find 2 factors of ax squared that when we multiply, we will get ax squared. So from this, if I want to split ax squared, I'm going to get ax times x. So x times as will give me ax squared. Likewise, 2 numbers, if I multiply, I will get c, are going to be, let's say 1 times c is going to give me c. Then this is only possible if this will be your factors. If you have the final duration that ax times c, ax times c plus x times 1 is equals to bx. Let me limit the writing and bring it a little bit closer. When we have ax times c plus x times 1 equals to bx, meaning that when I multiply this and this, if I sum the results and I get the coefficient of x, which is bx, then if this is possible, then my solution will be ax plus 1, then x plus c. This will be my factorized solution to the question. Now let us try with some common questions and then we'll see how we sum everything up. So the question is x squared minus 5x plus 6. So we use the tree, we draw solution. We have our simple tree, then we put in, here is x squared, then 6. Okay, good. Then what are the two variables that if I multiply I will get x squared? I know x times x, x times x, we say when we are multiplying we add the exponents. Then what are the two numbers? If I multiply I'm going to get positive 6. Bear in mind that when the two numbers sum up we must get negative 5x. So what we are going to do is that I'm just going to look at two numbers. 2 times 3 will give me 6. 2 plus 3 will give me positive 5 but not negative 6. So I just have to look at the alternate way. So what I do now is that then negative 2 times negative 3. Good. So negative 2 times negative 3. When I multiply negative 2 and negative 3, I'm going to get positive 6. Then I'll check and see. The checking shouldn't come on your solution. So your checking will be x times negative 3 plus x times negative 2. What am I going to get? X times negative 3 is going to give me negative 3x. Then plus x times negative 2 will also give me negative 2x. Okay, so negative positive will be negative. So in answer, I'm going to get this to be equals to negative 5x. So because the sum up is negative 5x, then my solution will be x minus 2. Let me go a little bit up. X minus 2, then x minus 3. This one becomes solution to the quadratics. This is using the tree method approach. Note that the question we use is a wired pass question. Let us look at another one. Okay, let us use the same approach to solve the second question. Now the second approach is giving us in solution. We draw our two bars. We got 3x squared 2. Then 2 factors of 3x squared. When I multiply will give me 3x squared. I'll have 3x then x. When I multiply this, I'll get 3x squared. Then 2 factors of 2, that when I multiply, I'll get positive 2. Mind you, the figure is going to substitute negative 5x. So in this case, if you are going to make this one be positive, means that it's going to be affected. So the best thing to do is that, because this one is starting with the highest figure, start with let me say the one that perceived to be higher numerical value. So I will start with negative 2 here, then negative 1, neg 2, then neg 1. Good. So I will try and see whether it will agree. So I've got neg 1 times 3x will give me negative 3x. Okay, then x times negative 2x will give me plus neg 2x. Okay, so this plus that, neg 3x plus neg 2x is going to give me negative 5x. So it means that the aspect here has been solved. So once it has been solved, then my solution will now be 3x minus 2, then x minus 1. Now this one becomes solution 3x minus 2, then s minus 1. This one becomes solution to the quadratics. Now we try the general method. Good. So using the general method, this is the approach. We have generally the quadratic function is given as ax squared plus bx plus c. So what you do is that you multiply the coefficient of x squared by the constant to get AC. Then you find the factors of AC, that when you add will give you B, the coefficient of S, but when you multiply will give you AC again. So actually, if you have a question like the one we just solved, let us try the two examples we have with. The first question was given as x squared minus 5x plus 6. So what we are going to do is that we are now going to look at factors of, we are going to multiply the coefficient of a, which is x over here, the value is a. We are going to multiply a here, which is 1, by the constant 6. So 1 times 6 is going to give me what? 6. Okay, if 1 times 6 is going to give me 6, then I find the factors of 6. So 6 factors. So find factors of 6 that when we sum up will give us negative 5. So we know we have neg 1, 1, negative 2, 2, neg 3, 3, then neg 6, 6. So two of these factors, when you multiply, you will get positive 6. But when you add, you will get negative 5. So realize that negative 3, negative 2 is equals to negative 5. Negative 3 times neg 2 will give me positive 6. So in place of 5x, we have got negative 3, negative 2. We just have to arrange the equation in such a manner that it is well accepted. So we see we are now going to substitute the negative 3 and negative 2 into the position of negative 5x. Okay, so what we have now is we're gonna write it in a way to be able to be contained. So this is x squared. Let me use the blue ink. We have x squared, then minus, let's say 3x. Know that the figure is going to represent this. So the negative 2, negative 3 and negative 2 from here, which comes, must be arranged in such a manner that when you add, you will get the 5x. So plus 6. So this is what we have. Good. So what we do now is we try to group it. So grouping, we'll have x squared minus 3x in another bracket plus here. I told you in between the brackets must always be positive. So we got negative 2x plus 6. You close this bracket. Good. So you now factorize the function. So let us solve and factorize now. Now what we can say is that the least term over here is x. So we bring out our x, and we'll bring our s out. Then x will go to s. We've learned earlier that is the same as x squared divided by x. So this is 1, this is 2. You subtract 1 from the exponent and you'll be left with x. So we got x. And 3x divided by x, meaning x will cancel. I'm going to get minus 3. Then the least term over here is negative 2. So negative 2 to negative 2s will give me x. Then negative 2 to, that means we got 6 divided by negative 2 is going to give me negative 3. So negative 3. So in all cases, what will be in a bracket must be the same. So we got s minus 3, s minus 3. So we got x here minus 2, then x minus 3. Whichever method appeals to you, you take it. You can either use this tree method, this method, or the tree method. At the end of the day, you come by the same answers. Okay. So we have some past questions on this topic. Let us see how we do justice to it by solving it. Good. Let's start with the first part, whereby we have to factorize completely the questions. So note, this is BC 2015. This BC 2015. So we look at the first one, solution. Move a little bit up. Good. Now we have the question as, that is I, x, y, 3x plus 6y plus 18. Good. Let's see how we can group this so that we can simplify it completely. In stages like this, the questions have already been grouped for us. We got x and s, so let the s be at one side. Though there's y here, but don't worry about it. So I'm going to have x, y plus 3x. Then we have here positive 6y plus 18. Good. And always bear in mind that before you group, you just check if you are to send y here, or you are to bring y here and 3 here. At the end of the day, you still come back getting the same thing, but you must know how you are going to figure out the items. So in order not to confuse myself, I just start. Now the common term here is x. We can see the common term there is what? X. X is the commonest term here, so we pick our x out. So as I said, x, y divided by x. X cancels x, I'm left with y. Then the same thing, x cancels s, I'm left with 3. Good. So the least term here is what? 6 can go to 18, so 6 is the least term. So 6, I'm going to get y. 6 to 18 is 3. Good. So I go further. I go further to the left hand side, and then bring out the general aspect. There's x out, 6 out, and what is in the bracket is the same. So I can conclude that I have in the bracket x plus 6, then y plus 3. So this is a factorized aspect of the question. Very simple. Let us look at the question 2. So let's see. This question, we are more fortunate it has been factorized for us, and but we are being asked to, so we just follow it. If I can see that m plus n, so over here m plus n out. If I pick m plus n out here, I'm just going to work it as m plus n here, m plus n here. So in grouping, I'm going to get into bracket m plus n. It's occurring 2 times in the same bracket, and the other bracket will have 2x minus y. Then this minus x. So what happens is that this x will reduce x. There's x here, which is going to reduce this x. So my final value will be m plus n. Then when I take s from 2s, I'll be left with s minus y. So this one becomes my solution. So we have mn plus mp plus nq plus pq divided by n plus p. When you have such a relation, always look at the aspect of the denominator and see if you can factorize the numerator to get n plus p, so that the denominator aspect can cancel it out, so that the function becomes very easy. So going further, let me use my the equivalency sign. Let me clean it in case becoming. So let's use the equivalency sign here. Good. I've got mn mp. So mn mp, the least term here is what? M. If m is out, m to mn, I'm left with n. That means mn. Good. And m to mp will give me plus p. So we've gotten the first part. So plus, so let this place always have plus. And the commonest term here is also q. So q out. So if q is out, then we q to np will have n, then plus p, all divided by n plus p. Okay, we have the same np in the bracket and what mk plus q outside, so we just do it m plus q n plus p, all divided by n plus p. There's n plus p here and there's n plus p here, so it will cancel, and my final answer will give me m plus q. Good. So we have been able to look at all the aspects of the quadratic and the factorization. So our next topic will be on the linear equation and the linear inequalities.